Okay, hi everyone. So for this video, I will discuss the unit vector, the cross product, and the dot product. So what is a unit vector? A unit vector is a vector that has a length or a magnitude of 1. So basically in physics in general, no, we utilize unit vectors to represent a direction in space. So I won't get things too complicated. We already know that, let's say we have a vector A, for example, no? We could represent this as a terminal point with a horizontal axis A sub x and a vertical axis A sub y. So in other words, we could represent this in this way or in this other way. So they are basically the same. Okay? And then the rules will still apply, but instead of the usual coordinate pair, we could represent this into this form. So that goes the same with adding vectors. We can just add their components respectively, just like what we did with the previous examples. Right? Okay, so let's say we have this problem. We have A, B, and C vectors. We want to find the magnitude and direction of the vector D. So how do we do this? So for vector D, we want to do this operation. So we have 2 times vector A minus 3 times vector B plus C, or the C vector. So let's just substitute the values here. We have the given 3 vectors. So 2 times 2i minus 4j, and then we have minus 3 times negative 3i plus j, and then plus negative 5i minus 5j. Okay, so this is all in meters. Let's just write the units later. So substitute, or sorry, distribute this 2 and this negative 3, and then we could add this later. Or what you could do, you could just do this directly. We could do this. So let's say we have 2 times 2. Okay, so we will add all the components of I, which is basically just the magnitude of the x components. So 2 times 2, we have negative 3 times negative 3. And then we have negative 5. So this is the component of the horizontal component I hat, or just I. Okay, and then we have the y components. We have here plus 2 times negative 4. And then we have negative 3. And then 1. And then negative 5 minus 5. Okay, so if we simplify this, we have here, we have 4, sorry, we just add this directly, we have 4, we have 9 minus 5, so this will be equal to 0, right? No, not 0, but we have 8i, no, to be exact. And then we have, for the y component, I'm really sorry, we have negative 8 minus 3 minus 5. So this will be negative 16. So we are looking for the magnitude. So we want to find the hypotenuse of this. We can call this d sub x and this of y. So to find for the length of d, or of this d vector, we find the square root of dx squared plus dy squared. So sometimes I will utilize this notation or this notation. It is the same. Ano? So this is also the same as this. So substituting the value, we have 8 squared plus negative 16 squared. Sorry. Okay, so where is the calculator? Sorry. Square root of 8 squared plus 16 squared. We could just omit the negative sign since it will cancel out. So the answer here will be 17.89. So this should be in meters. And then for the angle, since we have a positive x and a negative y, take note of that. So at what quadrant should it lie? So if the x is positive, this will be the direction now towards the right. And if your y component is negative, then it will be downwards. So this will be negative. So therefore, it would lie at this quadrant. So fourth quadrant, therefore, we are trying to find the angle theta here. But we can only find, for now, this angle alpha. So therefore, we can say that theta, or sige, we could just add alpha and theta, and this will be equal to 1 revolution, which will be 360 degrees, as you can see. Now, so 1 whole revolution is 360, therefore theta plus alpha will be 360. So therefore, theta is equal to 360 minus alpha. If we transpose this alpha to the other side. So theta is equal to 360 arctangent, no? Arctangent. So y here, the y here is negative 16, the x here is 8. So theta, we have here negative 16 over 8. So we want to find the absolute value, so we will just erase the negative signs. We assume that alpha is positive here. Okay, so we have 360 minus arctangent 16 over 8. Ayan, so we have 296.6 degrees. Okay, so that's it for this problem. Okay, so let's move on with another example. So given vector A and then vector B, no, we want to figure out what are the components of C. So given the components of A and B, we want to find the component of C if this is true. So how do we do that? So the first thing we should do, actually guys, we want to first solve C. So we want to manipulate the equation so that C will be equal to the another function. So transposing this one to the other side, we have 3C is equal to negative B will become positive, positive A will be negative. And then they divide both sides by 3. So this will be C is equal to 1/3 of B minus 1/3 of A. Okay, now we can substitute the values of B and A. So 1/3 of B, which is 13.2 and negative 6.6. So we have 13.2 I hat minus 6.6 J hat. So it depends on you actually if you want to show the hat, no, but if you have a hat in your I and J vectors, it means it is a vector. If you remove this, it is just a variable. But anyways, we can omit that sometimes to save time as long as we are in the same context. Okay, sige, we have minus 1/3 of A, negative 8.7 I, and then 15. So all of the vectors are in centimeters, so we will take note of that for later. Okay, let's do this again. So we have 1/3 of 13.2 and then minus 1/3 negative 8.7. So what we just did here, we just added the components of x. And also we distributed this, and then all the x components here added. And then for the y components, we have 1/3. Also distribute this as well. 1/3, 6.60. And then we have negative 1/3. And then 15. And then j hat. So simplifying this using our calculator, we have here 1/3 times 13.2 minus 1/3 multiplied by negative 8.7. Okay, so this will be our x component, 7.3 I hat. And then for the y component, I think I will just change this one. Is this negative? This is supposed to be negative, right? So this is supposed to be negative, so I will put negative here. Sorry guys. Ayan. So negative 6.6 and then negative 1/3 times 15. So the y component will be negative 7.2 j hat. So this is your final answer for the components of C. So basically C is this vector in unit vector rotation form. Okay, let's move on to the last two topics, the dot product and the cross product. So I won't make things too complicated again. We have here, given two vectors A and B, we can find the dot product of A and B by multiplying the components, component-wise. So let's say we want to find the dot product of A and B, we just multiply A and B, no? Basically AX and BX, AY and BY, and so on. Okay? So just remember this formula, guys. And also this one is important. So I won't show you the proof anymore of this equation, not to save time. But just remember this one. So what does this mean? the vector C and B is equal to the magnitude of A times the magnitude of B times cosine theta. So we will show this later through an example. Okay, we also have the cross product. So with the cross product, before you memorize this formula, the cross product basically is just a determinant. So let's say we have ijk in the three-dimensional space. So this should be a hat. To notate that it is a vector. So what we do here is, let's say we have two vectors, ax, bx, bz. Sorry, not b, but ay and az. I'm sorry for that. And then we have bx, by, and bz. So this two represents two vectors. For example, this one is vector A and this is vector B. So if we evaluate this determinant, this will be equal to this. No? Using the crisscross rule, you can evaluate a determinant. So more into that, I hope you could study determinants. So basically this is a determinant. Okay, and so remember this formula, guys. And also this one. So for that product, it is cosine, but for cross product, we have sine. All right. So take note of this. There is a rule about the vectors involved in the cross product of two vectors. So usually we have a three-dimensional space when we do the cross product. So if your vector is a two-dimension, you just put 0 for A sub C and B sub C. So if your vector is two-dimension, meaning you don't have this, you will just add here 0 and 0. No? Okay? So basically, if you have two vectors, the cross product of these two vectors should be orthogonal to both of the vectors. Or in other words, it is perpendicular to both. So as you can see here, let's say you have two given vectors, A and B, then it should be orthogonal or perpendicular, meaning we have a 90-degree angle in between. Okay, so let's solve some problems. So given vector A and vector B, find the dot product of A and B, the angle between A and B, and the cross product of A and B. So one thing to remember, guys, that I forgot to say, dot product is commutative, meaning A dot B is also the same as B dot A. But the cross product is not commutative, meaning this is not equal to B cross of A, but instead this is just the negative of that. Okay, so remember this one as well. So again, dot product is commutative, cross product is a sort of commutative, but you have to negate the sign. Okay, so remember this. So I will just erase this for now. So we want to find A dot B. So for A dot B, this is equal to the multiplication of the components. So we have 2 times 1 for I. Sorry, not for I, no. But we just multiply this entry-wise and then add them. So we have 3 times negative 2. So we have 3, negative 2 here. And then negative 5 and 7. So we have negative 35. So we have 2, negative 6, negative 35. So this will be negative 41. Plus 2, we have negative 39. That's it. It's that simple. Okay, if you want to find the angle between A and B, you could utilize the identity for the dot product again. So A dot B is equal to the magnitude of A times the magnitude of B multiplied by cosine theta. Now, how do we do this? So we know already this dot product. We are good to go for this. We do not know yet the magnitude of A and the magnitude of B to find the to find the angle theta. So basically, we know how to do this anyways. Okay, so let's just solve for theta. And then we can just input the formula for this one later. Okay, so we have here, we could cross multiply this one over A and B is equal to cosine theta. Therefore, theta is equal to, so we could use the inverse cosine. Okay, so we have A dot B over the magnitude of A vector multiplied by the magnitude of the B vector. Okay, so theta is equal to, so we know that this one is equal to negative 39. And then let's solve for the magnitudes. So we have here negative 39, and then all over, how do we do this? So that's just a square root of the squares of each components. So for A, we just square this. We have 2 squared plus 3 squared plus negative 5 squared. And then multiplied by the square root of 1 squared. Okay, so 1, negative 2, and 7. Squared. 7 squared. Okay. So simplifying this, we could utilize the calculator. Our calculator. We have here. Okay, what do we have here? We have inverse cosine. Where's that? Inverse cosine and then over negative 39. So we have to incorporate the negative sign and then multiplied by square root of 2 squared plus 3 squared plus 5 squared. So the negative side will cancel out. So I won't show this anymore. And then square root of 1 squared plus 2 squared plus 7 squared. Okay, so the angle will be 149 degrees. So theta will be equal to 149.4 degrees. So this will be your final answer for the angle in between A and B. So if you have a vector A and B, the angle here will be this theta. No? Okay. So let's talk about the cross product. Okay, for the cross product, what we could do here is to perform the determinant or evaluate the determinant. So the cross product of A and B vectors, that will be equal to ijk and then ax, ay and az, and then bx, by and bz. So be mindful that if A is first, A will always also be first here. Okay, so let's substitute the values. So we have I, J, K. So we have, what is the value? 2, 3, negative 5. And then we have 1, negative 2, and 7. Okay, that's right. Okay, so we want to evaluate this determinant. So how do we evaluate determinants? You will discover this in your linear algebra class, hopefully. Okay, so how do we do this? What we could do is the crisscross rule. For 3 by 3 matrices, what we should do is to duplicate first the first two columns. So this first two columns will be duplicated to this right hand side. So we have I, 2 and 1, J, let's make this red. So I, 2 and 1, J, 3 and negative 2. So crisscross rule, basically we have this criss, so down, and then cross, so up, and then perform this operation, multiply the one that is crossed, and then subtract these two evaluations. So this will be equal to, so we just multiply this, we have I times 3 times 7, and then plus we have J times negative 5 times 1, and then plus we have K times 2 times negative 2. Alright, and then for the up, so we start with this one, we have 1, so minus, don't forget the minus sign, 1 times 3 times K, and then we have plus negative 2 times negative 5 times I, and then 7 times 2 times J. Okay, so let's evaluate this. Let's simplify everything. We have 21I minus 5J minus 4K, and then minus we have here 3K, or it should be negative or positive, or wait, it should be positive, so there should be 3K plus 10I and then plus 14J. So we could just distribute this negative sign, or actually you could just do this already. You could just add this 2, no, if you want, but you have to distribute this negative sign. So let's rewrite this anyways. So minus 3K minus 10I minus 14J. So add the like terms, or the component wise addition. We have 11I, and then for the J, we have here negative 19J, and then for this one we have negative 7K. So this will be your cross product. No? Okay, so that will be all. Thank you guys.